Hey guys, welcome back to the channel. In this video, we're going to be talking about series from Cambridge Additional Mathematics, IGCSE. And in this topic, we're going to learn quite a lot. So we're going to be starting off with the binomial theorem. In this, we can use two methods, which is like the Pascal's triangle and also like using combinations. We're going to start with that, and then we also go into geometric progression, arithmetic progression, converging series. So there's a lot to unpack here, so stay tuned. Okay, so first of all, we're going to start with Pascal's triangle. Before we go into what it is, I just want to give you like an overview of why it's being used here. So when you want to expand something like x plus 1 whole squared, what do? You do x plus 1 multiplied by x plus 1, right? And then you multiply the terms and then you try to add the like terms. You could probably do it till like to the power of 3, power of 4. But after that it becomes really tedious. So you can't really do so many, you can't be like x plus 1 to the power of 100. How do you do that? You would have to multiply x plus 1 by itself 100 times. Just imagine how much time it would take. To solve this problem, mathematicians came up with something called as the Pascal's triangle or the binomial theorem. Pascal's triangle is an aid for binomial theorem. So I hope you've understood why we use this, and let's actually talk about how to use this. So first, I'm going to tell you like how to draw the Pascal's triangle. So first you have to write 1 and 1. It looks like a triangle, so that's why it's called the Pascal's triangle. So you write 1 and 1. And now here you can see 1, right? And this is considered 0. So you have to add 2 of these numbers to get the third value. Just like that here. This is 0, so it's going to be 1. And then from here, you add these two numbers to get this. Add these two to get this number. So you keep doing that like as much as you want. But this method is also not very efficient. Let's say you want to find x plus 2 whole to the power of 100. You'd have to write this like 100 times. Not 100 times, it's going to be like 100 plus 99 plus 98 plus 97. So many numbers you'll have to write. So that's also not very efficient. But if you're trying to use this for like small numbers like to the power of 6 or to the power of 7, it would be efficient. So therefore we use this. So I hope you've understood like how to derive the triangle. And now we're going to talk about how you actually use it. So when writing expansions of a plus b to the power of n out in order, you have to write it in this manner. So if it's to the power of 1, you put the coefficient, multiply that by the first term, and then again 1b. And then you keep doing it that. So you can see the pattern, right? 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 6, 1, 4, 6, 4, 1. So you keep doing that. And here the term is 4, 3, 2, 1, 0. The power of the first element in the brackets, it will keep going down. The number will keep going down. It will be like 4, 3, 2, 1, 0. So whatever the power is, you have to multiply it here also. And then you keep going down until it's 0. But then for the second element, you have to stop with 0 and go on till this number. It's that simple. You just have to use the triangle and use like the ascending and descending order for like the first and second element respectively. And then that's it. You get the answer. So it's that simple. Now let's just look at this also so that you're clear. I'm going to cover this so you can like, actually no, that's not required. But anyways, we'll talk about this. So the first element will be 1, like the coefficient will be 1. and then multiply a to the power of 3 and b to the power of 0. You can write it out in the start so you don't get confused. And then the next number in the Pascal's triangle is 3. So you write 3 and then subtract 1 from this and add 1 to 0. So you get a squared b, and then keep doing that until you get only this term. And that's how you do it. And some of the things you have to keep in mind is that each row always starts and finishes with 1. There can't be any other number other than 1. And also, each number is the sum of two numbers in the row above it. So you can think of this as like a small triangle inside of the big triangle. So it's going to be the inverted triangle inside the big triangle. That's how you can remember it. And yeah, so that's how you do it. And the pattern keeps repeating. We have x plus 1 plus x to the power of 3. Like we discussed before, we have to use the Pascal's triangle. So we have 1, 1, 1, 2, 1, 1, 3, 3, 1. And therefore, we use this row, the third row to solve this. First, let's write this down. This is 1 to the power of 3 into 1 plus the coefficient will be 3 multiplied by 1 to the power of 2 x to the power of 1 plus 3 multiplied by 1 to the power of 1 multiplied by x squared plus 1 into x to the power of 3. We get 1 plus 3x plus 3x squared plus x cubed. So this is how you do it. With practice, you'll be good. And now let's try to solve this also. Let's use the same Pascal's triangle. So this is 1, 4, 6, 4, 1. I'm just going to rewrite this here. So 1, 4, 6, 4, 1. This is going to be 1 multiplied by 2x to the power of 4 plus 4 multiplied by 2x to the power of 3 multiplied by 5 plus 6 into 2x to the power of 2 multiplied by 5 squared plus 4 multiplied by 2x into 5 to the power of 3 plus 1 multiplied by 5 to the power of 4. Let's plug these values into a calculator to find the answer. So this is going to be 2 to the power of 4 is 16. So 16x to the power of 4 plus 4 into 2 to the power of 3 multiplied by 5. That's 160 x cubed plus 6 multiplied by 2 squared into 5 squared. That's 600 x squared plus 4 into 2 into 5 to the power of 3. That's 1000. That's 1000x, and then 5 to the power of 4 is 625. So that's the final answer. This is also going to be 1, 4, 6, 4, 1. So the first term is 2x to the power of 4 plus 4 multiplied by 2x to the power of 3 multiplied by y plus 6 multiplied by 2x to the power of 2 multiplied by y squared plus 4 multiplied by 2x multiplied by y cubed plus y cubed, y to the power of 4. This will give us 16x to the power of 4 plus 4 into 2 to the power of 3 is 32 x cubed y, and then 6 into 4 is 24. 24 x squared y squared plus 4 into 2, which is 8. 8x y cubed plus y to the power of 4. This is the final answer. For this one, we use 1, 3, 3, 1. This is y cubed plus 3 multiplied by y squared into 4 plus 3 into y multiplied by 4 squared plus 4 to the power of 3. This is y cubed plus 12y squared plus 48y plus 64. This is the final answer. And with that, we're done with all of these questions. The second method of solving a question like that would be to use the binomial theorem. It's pretty similar to the Pascal's triangle in terms of the logic, but the way you derive it is pretty different. So what we're trying to find in both the Pascal's triangle and the binomial theorem is to find a value or a constant that we have to multiply with each term. In the first method, we write down the numbers and then we add the corresponding numbers that are above a particular row. And that's how you find it. But in the binomial theorem, you have to use the NCR function on your calculator to find the coefficient. Either way, you're going to end up with the same answer, but this method would be better because you wouldn't have to write down every single row in order to find a particular value. And here, the Pascal's triangle can be used to expand this function for any positive integer. But if n is large, it can take a long time. So that's what I told you before. And combinations can be used to help expand binomial expressions very quickly or more quickly. So we've learned about combinations in our, I think, 8th chapter. So I'm pretty sure you're like very familiar with this. And now we just have to like use that here. And so it's like a plus b to the power of n. So this would be nc0. And then the second term would be nc1. Third term is nc2. If you're getting confused, then just think about the power of the second element. So the power of the second element is all the first term, but its power is 0. And therefore you do nc0. And then here in the second term, the power of b is to 1. So therefore you do nc1 and so on. So if you're trying to find the coefficient for the second term, we have to do 2 minus 1, 1. If you want to find the coefficient for the fifth element, it's going to be 4 because 5 minus 1 is 4. So you do NC4 and so on. This is very similar to like finding combinations in that chapter. Just have to plug this into your calculator. There is a function which says NCR and you just use that to find it. And this is the general formula. You can use this. I'm pretty sure it's going to be given in the formula booklet. Even if it's not, then there's no problem because this is just logic. If you know the logic of like the ascending and descending powers and the logic of the NCR, you're fine. You'll be able to answer every single question that might come. I have selected some questions that will be seen in your paper. I'm pretty sure a question like this one or this one is going to come in the exam for sure. There's going to be at least one question that will ask you about the term independent of x, or you have to find a coefficient of a particular value. So this is what you're going to get in the exam. This question and this question are just for practice, but you're going to use the knowledge that you have learned by solving these questions into finding the answer for a question like this or this. Okay, the first one is just an example, and there's the answer given below. So I just want to walk through this with you so it's pretty clear. So we have to use the binomial theorem to expand 3 plus 4x to the power of 5. So first we have to write 5c0. We know that 5c0 is always 1. So we can just ignore that. So we're going to get 3 to the power of 5. And then we write 5c1 multiplied by 3 to the power of 4, because we're going in, because the powers of the first element is going to decrease by 1. So therefore it's to the power of 4. And then the second element, it's going to be to the power of 1. So 4x to the power of 1. And you write that for every single term. And then once you simplify it, this is what you're going to get. So yeah, I hope this is clear. You can just give this a practice and see if you get the same answer. The next question is a little complicated. You'll have to use your brain if you don't want to write every single term in this. So you can see that when x is in the second place, or like if it's the second element in the expansion, then you're going to get it in ascending order, right? So if you were to write this in the normal way, you'd have to write about 21 terms in order to get this. But if you think about it, and if you write this as minus x plus 2 to the power of 25, then doesn't it become more simple? Because then we're going to go in descending order of x, meaning we start with 25 and we go down to 0. And therefore, it's more convenient for us to write minus x plus 2 whole to the power of 25. This way, you don't have to write about 21 terms, but you just have to write 5 terms if you write it in this manner. And now let's expand this. This is going to be minus x to the power of 25 plus 25c1 multiplied by minus x to the power of 24 multiplied by 2 to the power of 1 plus 25c2 multiplied by minus x to the power of 23 2 to the power of 2 plus 25c3 multiplied by minus x to the power of 22 multiplied by 2 to the power of 3 plus 25c3 4 multiplied by minus x to the power of 21 multiplied by 2 to the power of 4 plus 25c5 multiplied by minus x whole to the power of 20 multiplied by 2 to the power of 5. And therefore, we just got this in 5 terms. 5, yeah. And now we just have to simplify this, plug this into your calculator, and we get, for this one, we get 53,130 multiplied by 2 to the power of 5. We get, the final answer would be 1700160 x to the power of 20. Just imagine you had to do this with the Pascal's triangle, how many rows we'd get. And therefore, the binomial theorem is much more efficient than using Pascal's triangle. So this is the answer. And also, since we've written this down, I want you to observe each term. There is a pattern going on, and I think it's going to be very helpful for the confirmation of your answer. Do you see it? If not, I'll explain. So the first term, the power of the first term is always the difference of n and r, if you notice. It's 25 minus 1, that's 24. And the power of the second element is always the value of r. And once you add these two, you always get n. If you look over here, we get 25 minus 2, that's 23. And then 2 and 2, when you add these, you get 25. If you look over here, 25 minus 3 multiplied by, okay, this is 22. So 25 minus 3. And then this is 3 and this is 3 also. When you add these two, you get 25. And that's how you can confirm your answer. Okay, now let's say you wanted to find the coefficient of, let's say, x to the power of 16. You didn't want to write this. What do you do? So first, you have to find a number. So it's basically 25 minus the number, which will become 16. So that's what we're doing, right? So x will be 9. And we get 25c9 multiplied by minus x to the power of 16 multiplied by 2 to the power of 9. And that's how you use logic and you solve this. You don't even have to expand about, let's say, 16 terms or 10 terms to actually find this answer. You just figure it out in like less than a matter of 15 seconds. And that's how this little trick will help you confirm your answer. If you'll okay, in the exam you'll have to write down these steps, otherwise you won't get the mark. But just to confirm your answer, you can use this method. And therefore, this method is so much more efficient than using Pascal's triangle. And this method that I've shown you right now is so much more efficient than trying to expand every single term of this. This chapter is all about finding the tricks that will help you solve the questions faster. And also, it will help you verify each question. If you carefully observe what's going on, then all of this will make sense to you. Rather than just using the formula, try to understand what's going on. Okay, let's solve a bunch of questions. So first, let's start with this one, and then all of these have the same question. So it's basically to find uh, the term x cubed in each of the following. For this one, let's use the trick that we figured out in a previous question. All right, so we have to find the term in x cubed. So we know that 5cr, okay, let's just rewrite this as x plus 2 to the power of 5. These two are basically the same thing. So therefore, we know that 5cr into, let's say this is x to the power of 5 minus r multiplied by 2 to the power of r. This is literally what we learned in the previous example, right? So now let's use the same concept to make this a lot more simpler. So we know that the term must be to the power of 3. So therefore 5 minus r will be 3. So r is 2. This is going to be 5c2 multiplied by x to the power of 3 into 2 squared. We get 5c2 is 10 multiplied by 4 is 40. So this is 40x cubed. This is a very quick and efficient method of solving such type of questions. And now let's do the same thing for part B. Let's rewrite this again. So this is going to be x plus 5 to the power of 8. So it's going to be 8cr multiplied by x to the power of 8 minus r into 5 to the power of r. So we know that the power of x is 3. So we have to set it to 3. So 8 minus r is 3. And r will be 5. So it's going to be 8c5 multiplied by x to the power of 3 multiplied by 5 to the power of 5. We get this is, I think, 175,000. Yeah, pretty sure. So this is the answer. Let's solve the last question. This is also very similar. So it's going to be 6 minus r is 3, and r is therefore 3. So it's going to be 6c3 multiplied by 2 to the power of 3 into 1 to the power of 3. This was to the whole. So it's going to be 160x cubed. And yeah, with that, we're done with this question. If you want, you can expand this from the first term to the third term, or you can do it this way. But if you want to check and verify and get some more practice, you can do that also. Let's solve this one. So we have to find the term independent of x. The meaning of independent of x means the power of x is 0. That is what the term independent of x means. That means it has no x term. And that the only way that is possible is if x to the power of 0 exists. So we know that something to the power of 0 is always 1. And so that's the principle we're going to use here. We have x, and then we have 1 divided by 2x squared. So we can go through each scenario and try to find the answer, meaning we can expand this. So in the exam, you'll have to expand every single term in order to do this, or you can use the method here. Either way works, but if you're trying to use the second method, please be very careful. You have to write every single step, and you'll have to write a lot more than if you just expanded it. So I'd always recommend that you always use the first method, meaning you expand every single term to do it, because that way you won't lose marks. But if you try to use the second method and you mess up the steps or something, or the way it's supposed to be written, you're going to lose a lot of marks, and therefore I don't really recommend using that. But you can always use that method to check whether the answer is right or not. So I will explain both the methods, but make sure that you use the first method in the exam. Okay, let's expand this. So this is going to be n9c0 multiplied by x to the power of 9, and this is going to be to the power of 0. So 9c1 into x plus 1 divided by 2x, and then plus 9c2 multiplied by x to the power of 7 multiplied by 1 divided by 2x squared whole squared, plus 9c3 multiplied by x to the power of 6 multiplied by 1 divided by 2x squared whole to the power of 3. After this step, you can write plus so on till 1 divided by 2x squared whole to the power of 9. So here we got our term independent of x, because here we get x to the power of 6, here we get 1 divided by x to the power of 6. And therefore they cancel out, leaving us with just a numerical answer without x there. And so now we'll expand this, or simplify this. These get cancelled out. Show that in the exam. That's 9c3 divided by 8. Yeah. That will give us 21 divided by 2. And that's the answer. And now if you want to do it the second method, I will show that also. So first, let me erase all of this. Actually, I'll move it that side. Okay. So what you're going to do is first we write 9cr. And this is going to be x to the power of 9 minus r multiplied by 1 divided by 2x squared to the power of r. And now what you're going to do is you're going to simplify this. You're going to write 9cr multiplied by x to the power of 9 minus r. Let this be this multiplied by x to the power of negative 2r. You just put this towards this side, multiplied by x to the power of r. So 9 minus r multiplied by x to the power of minus 2r. We know that this will be 0 because, well, it's independent of x. And if we have this, we can write this as minus r. 9 minus r minus 2r is 0 because of like the property of indices that you just like add these two. So this is going to be 9 equals 3r, implies r equals 3. So when we have r as 3, we can plug this back into the equation here in this step, to find it. So we get 9c3 multiplied by 1 by 2 to the power of 3. This is literally what we got here. And therefore, we get 21 by 2, which is also 10.5. This method can be tricky for some people if you're not that good at like exponents and like adding them, subtracting them. But you could also potentially lose a lot of marks if you don't properly write these. And therefore, it's better to use this. Either way, it will work. The next topic is arithmetic series. So I'll just give you a brief introduction as to what it is. So an arithmetic series is a sequence of numbers that follow a particular order. So the sequence, which is 5, 8, 11, 14, 17, it's an arithmetic progression because each term differs from the term before by a constant. This constant is called the common difference. So if you can see, the difference between these two terms is 3, and the difference between this is also 3. The difference between two terms must always be a constant. But over here, if it were like 18, then it wouldn't become an arithmetic progression because it's not differing by a constant, I guess. So this is 3, 3, 3, and 3. And that is a series because it's differing by the same constant value. So the notation used for the arithmetic progression is A is for the first term, B is the common difference, and L is the last term. And the first 5 terms of an arithmetic progression whose first term is A and whose common difference D are, so the first term is A, the second term will be A plus D, the third term would be A plus 2D, fourth one will be 3, and then fifth one will be 4D, and so on. So if you see, the difference between the fifth and fourth term is D, which is the common difference. So the general formula for like the series is a plus n minus 1d. So if you want to find the nth term of the arithmetic series, then you will have to use the formula a plus n minus 1d. So for example, let's just see the fourth term. That means a plus 4 minus 1, which is 3d. So you know that's correct. And that's the introduction to arithmetic series. So next thing that we're going to learn is the sum of arithmetic series. So if you want to find the sum of a number of elements that follow the arithmetic series, then you'll have to use either this formula or this formula. So sum of the number of elements is n divided by 2 multiplied by a plus l. So you can, where a is like the first term and l is the last term. Or you can also take Sn is half n multiplied by 2a plus n minus 1d. This will be given in the formula booklet, so you don't have to worry about that. So here we're going to talk about the proof. So we know that Sn is basically the sum of the arithmetic progression, right? So we know that the first term is a, the second term is a plus d, and so on. So if we keep adding that, we're going to end up with this. And now if we reverse this, meaning we write L first, then L minus D, then L minus 2D, and so on, we can write this. And now if we add these, we're going to get 2Sn. So we know that these two are essentially the same, right? The first one and the second one. We know that they're the same thing. So we can write 2Sn equals n multiplied by a plus L, then a plus L, and so on. And therefore, we get 2Sn is basically n multiplied by a plus L. And if we divide both sides, then we get this. Therefore, this is the proof of like how you derive it. I think this was a mistake. It's just gonna be like a plus L, like n number of times. And therefore, I don't think this is supposed to be there. So I think it's just a plus L, a plus L. This is gonna be like n times of a plus L. And that's how we get the formula. And so like getting the second equation is also pretty simple. If you write L equals to a plus n minus 1d, we learn that the nth term is basically a plus n minus 1d, right? So if we sub that into like this equation, we get the same thing. And therefore, it is useful to remember the following rule applies to all of the progressions. So the nth term is basically the sum of n elements subtracted by the sum of all the elements from the first element to the n minus 1 element. So that's pretty simple because I can like show you right now. Because here, if you want to find this element, it's basically the sum of all of these minus the sum of these elements. And that's how you can think about this also. And this is how you find the sum of the arithmetic series. Let's solve the questions. In an arithmetic progression, the first term is 25. The 19th term is minus 38. And the last term is minus 87. Find the sum of all the terms in the progression. Okay, so first we'll write down all of the formulas we know. We know that Sn is n by 2 multiplied by a plus L. We have a and L, but we don't know n. But we could also use this formula. Sn is n divided by 2 into 2a plus n minus 1d. We could use either one of them. So first, let's try to find d. We know that a is 25, and we know that d 19, which is basically a plus 18d, is minus 38. So we can write 25 plus 18d is minus 38. If we move this that side, we get 18d is minus 63, and then we get d as minus 3.5. And now let's find the value of n. So we know that the nth term is n minus 1 d, right? So therefore we can write, if the last term is minus 87, we can write this. Minus 87 is 25 plus n minus 1 into minus 3.5. And if we rearrange the equation, we get the value of n. So first let's do that. Let's see how much we get. We get n is 33. When we sub this into this equation, a is 25 minus 87, we get minus 1023. So this is our final answer. Alright, so let's solve this question. So the 12th term in an arithmetic progression is 8. Okay, so we know that T12 is 8. And the sum of the first 13 terms, so as 13 is 78. So we have to find the first term of the progression and the common difference. Okay, we know that the nth term is a plus n minus 1d. So 8 is a, which we don't know, plus 11b. So this is our first equation. Now we know that the sum of 13 is n divided by 2 multiplied by 2a plus 11d. No, sorry, 12d. We can write 13 divided by 2 multiplied by 2a plus 12d. We can simplify this. So we get 13 multiplied by a plus 6d, and therefore this is 78. If we divide this by 13, we get 6 is a plus 6d, and we can rewrite a. This implies that a is basically 6 minus 6d. If we plug this back here, we get 8 equals 6 minus 6d plus 11d, and then we get 2 equals to 5d. Implies d is 2 by 5. So then if we rearrange it, we can get a is 8 minus 11d, so it's 8 minus 11 into 2 by 5. That gives us 3.6, sorry. So a is 3.6 and d is 2 by 5, which is also 0.4. Okay, so we have to solve the last one. Okay, so part A, we have to find the first term and common difference, okay. Sn is this. We have to find the first term and common difference. Okay, so you remember the formula where Tn is Sn minus Sn minus 1, right? So we just use that formula. Let's plug in. Okay, this is going to be simple if we start with n equals to 2 and n equals to 1, because then we can find the first term. So S2 will be 5 into 2 squared minus 3 into 2. This is 5 into 4, which is 20, minus 6. Therefore, it's 14. Then S1 is 5 into 1 squared minus 3 into 1. That's 5 minus 3, which is 2. And therefore, the first term is 2, because the sum of the first thing is 2. And then if we want to find the second term, we have this minus this. So 14 minus 2 is 12. And then if we want to find the difference of this, this is T2, right? So this is T2, and we have T1. If we subtract T2 from T1, we get the common difference. So D is 12 minus 2, which is 10. Therefore, the common difference is D and A is 2. And that's how you solve it. And then we have to find the expression for the nth term. Okay, we know that Tn is basically a plus n minus 1d, right? So we get, what's a? A is 2. It's not writing. A is 2 plus n minus 1 into 10. We can write this as 2 plus 10n minus 10. We get minus 8 plus 10n. So this is our final answer for part B. And with that, we're done with this topic. The last topic in this chapter is called geometric series. It's somewhat similar to arithmetic series, except there is something called as a common ratio, not a common difference. So let's start. So the sequence 7, 14, 80, 28, 56, 112 is called a geometric progression. Each term is a double the preceding term. So therefore, there is something called as the common ratio. The constant multiple is called the common ratio, and hence the notation used for a geometric progression is somewhat similar. So A will be the first term and R is the common ratio. So here you can notice that from this term to this term, there's the difference is like 7. But also if you think about it, this is double of this and this is double of this. And therefore they have something called as a common ratio between them. And hence, the first 5 terms of a geometric progression, whose first term is A, and common ratio is R, are A is the first term, AR is the second term, AR squared is the third term, and AR cubed, fourth term, and AR to the power of 4 is the fifth term. If you want to find the common ratio, in this one, you don't subtract the terms. Instead, you divide the terms. So to find the common ratio, you have to do term 5 divided by term 4, or term 4 divided by term 3, and so on. So that's the principle here. There's something called as common ratio and not the common difference. So if you know that difference, you'll be fine for this chapter. And then we have the sum of a geometric progression. So there are 2 ways in which you can represent them. Both of them will give you the same answer. So it can be shown that the sum of a geometric progression, Sn, will use the same notation here also, which is A multiplied by 1 minus r to the power of n divided by 1 minus r. R is the common ratio and n is the number of terms. Or you can just write this as A multiplied by r to the power of n minus 1 divided by r minus 1. Either way, you're going to get the same thing. Now let's go to the proof. So first we'll write Sn as normally. So similar to arithmetic progression, here we have to write down each term and sum them up. So it's like A plus AR squared, AR cubed, and so on. And the next line we'll write R into Sn. So we get AR plus AR squared, and so on. When we subtract 2 from 1, we get the following. So when you subtract this, you're left with this term and this term. And therefore, you can take Sn as common here, and then when you divide it, you get the sum. And therefore, this is how you derive it. And if you multiply the denominator by minus 1, you get the alternate formula as Sn is the opposite of that, which is this. This. So that's how you prove it. There is something called as the infinite geometric series. This is a series where the geometric series will converge, meaning it gets smaller and smaller and smaller. So you can find the sum of these, and the reason behind this is because as the number gets smaller and smaller and smaller, if you add the term, it's so insignificant that it won't contribute to the sum. And therefore, if it has a common ratio between -1 and 1, and they're not included, that means it will get smaller and smaller and smaller. It becomes so small at a certain point that it's insignificant. And therefore, you can find the sum of a geometric series. So an infinite series is a series whose terms forever continue. Continue forever. So the geometric series where A equals 2 and R equals to 1, sorry, this is 1 by 2. Okay. So this is the series. It will continue on, and then the number becomes so small at some point that it does not even matter that much. So now we're gonna talk about like how to find it and like the sum to infinity. So this is an example of a convergent series, like I told you, because the sum to infinity converges to a finite number. And if we consider the geometric series a plus ar squared plus ar cubed and so on, we have to consider this. So, and then if you want to find the sum, we use the normal formula that we talked about here. And then if the number is between -1 and 1, like I told you, then n gets larger and larger, and r to the power of n gets closer and closer to 0. Just think about like half to the power of like 1,000. What will it become? It becomes so small, right, that it approaches 0. And therefore, we know that as n approaches infinity, r to the power of n becomes 0. And therefore, using this principle, we derive that the sum to infinity will be a divided by 1 minus r, provided that r is in between -1 and 1. And so if it's in between 1 and -1, that means the geometric series will definitely converge. Okay, now you might be wondering why a divergent series we can't like find the sum of a divergent series. This is because consider that now r is 2. It will get like bigger and bigger and bigger. So you can't really like find a number because it doesn't converge to like a finite sum. It will keep getting bigger and bigger as you like find the terms. And therefore, this only works for a convergent series, or when like in our case, it should be between -1 and 1. The second and the fourth terms in a geometric progression are 108 and 48 respectively. So let's write that down. So T2 is 108. We know that T2 is AR, so it's 108. And the fourth term is T4 is 48. So we know that A into R to the power of 3 is 48. So given that that all the terms are positive and the first term, find the first term and common ratio. Okay, so let's find that first. If this is 1 and this is equation number 2, if we divide equation 2 divided by equation 1, we get r squared is 48 divided by 108. We get 4 by 9. And therefore, r is plus or minus 2 by 3. But it's given that all the terms are positive. Therefore, r is going to be only 2 by 3. So this is the only answer. And now if you want to find a, we just substitute that. So we get 108 divided by the answer. So therefore, we get a is 162. And now if we want to write down an expression for the nth term, we get Tn equals a, which is 162, multiplied by the common ratio, which is 2 by 3, to the power of n minus 1. This is our final answer. So let's solve the next one. The nth term of geometric progression is 30 multiplied by minus half to the power of n. We have to find the first term and the common ratio. Let's find T1. T1 is 30 multiplied by -1 by 2. That's a -15. T2 will be 30 into minus half squared. That will be 30 by 4, which is 7.5. If we want to find the ratio, we do T2 divided by T1. So that's the ratio. And this is going to be 7.5 divided by -15. That's a -1/2. And the common ratio is therefore -1/2. And if you want to find the first term, I mean, we already found it, so it's a minus 15. Therefore, a is minus 15 and r is a negative half. And now let's solve this question. We have to find the sum of the first 10 terms of the geometric series, 2 plus 6 plus 18 plus 54. We know that it's a geometric series, therefore a is 2 and r is 6 divided by 2, which is 3. Let's use the formula. R to the power of n minus 1 divided by r minus 1. A is 2 multiplied by what's r? R is 3. Therefore, we have to find the first 10, right? So 3 to the power of 10 minus 1 divided by 3 minus 1. If we solve this, we get 59,048. So this is our final answer. And let's solve the last question, which is related to the sum to infinity question. So the first 3 terms of a geometric progression are 25, 15, and 9. We have to write down the common ratio. So it's going to be 9 by 15, which is 3 by 5. And if we want to find the sum to infinity, we do this. A divided by 1 minus r. A is 25 divided by 1 minus 3 by 5. We get 62.5. So this is the answer. And with that, we're done with this whole chapter. Get at least 2 questions based on this chapter. Hence, this is very important. It's also as important as calculus. So you're going to get 2 questions. The first one is going to be a question related to the term independent of x. And then the other question will mostly be something related to either AP or GP. And yeah, with that we're done. Make sure you subscribe and leave a like.